All right, what we want to talk about today are angles and rays. So, what is a ray? A ray is a part of a line that consists of one endpoint and continues without end in just one direction. Okay, so it's one endpoint goes without end in one direction. So now let me draw you an example of a ray. I'm going to squeeze it in up top here. Doesn't matter which way it's pointing. There's my ray. Has one endpoint and it's going to go this way forever without end, as noted by the arrowhead on the end. Now, just like every other geometric figure we've talked about so far, this guy has to have a name. Well, before I can give him a name, I have to have some points on here. Well, I have point A and point B. Now, I want to give this guy a name. So if I'm naming this ray right here, I'm going to call this ray AB. Every other geometric term we had, lines and segments and planes, it didn't matter what order we put the letters in. If I'm talking about a ray, I cannot say ray BA. This name is not for this ray. This is no good. When you name a ray, the first letter in its name must be its endpoint, and then the second letter is the point that it is going to and traveling through. This is so that if I have just this notation on a piece of paper, I should know roughly what the ray looks like. Now, will he have other names? Possibly, if there are other points on that ray. So if I add point C on here, I can now call this ray AC. Because I'm still going to start at point A, but now I'm going to travel to and through point C. So as I travel to C, and then I'm going to keep on going, I'm going to go through B eventually. So ray AC is now the same ray as ray AB. Remember, you cannot flip the names when you're talking about rays. Opposite rays. They do exactly what the name there entails. They are two rays with the same endpoint, but they continue in opposite directions, hence their name, opposite rays. Now I'm going to draw another real quick, crude sketch here. So if I have a ray here going this way, I'm going to call it ray XZ. An opposite ray would start at X and go this way. So ray XZ and ray XY are now opposite rays. They both start at point X, and one goes to the left, one goes to the right. They go in opposite directions. Notice when you have a pair of opposite rays, they look a lot like a line. Now, we're going to take our rays, and with our rays, we're not going to be able to construct angles. An angle is two rays with a common endpoint. The rays are sides, and the common endpoint is the vertex. Two rays with a common endpoint. And the rays are the sides. So I kind of took care of a couple different vocab words in this one here. Okay? The rays are the sides. The common endpoint is the vertex, or the tip of the angle. So we got another crude sketch. One ray. Another ray. Common endpoint, there's your vertex. The vertex is the tip. The rays are the sides. Two rays with the same endpoint. Before we had congruent segments. Those were segments with the same length. Congruent angles are angles that are what? They are angles with the same measure. Okay? Congruent angles are angles with the same measure. Now in there in parentheses I have degrees. In this class, in geometry, we will measure angles in degrees. In other classes, trigonometry, pre-calc, calculus, you're going to talk about something called radians. We're not going to get into that today or within this subject, but there is two different ways to measure angles, degrees and radians. We're going to stick with degrees. Now, if you remember back to congruent segments, if I had congruent segments and I had two of them that were congruent, I could put the tick marks, right? Tick marks don't work for angles. So I will show you what we use for the angles. Here's an angle. There's an angle. These two angles obviously not the same, right? One's acute, one's obtuse. So they are obviously not the same. But through the magic of this little board here I have here, copy, paste. If I copy and paste it, now I know these angles are exactly the same because I did a copy paste. Even if I take this angle and I rotate it, these angles are still the same. If I do the same here, copy, paste. Don't have a whole lot of room to swing this one around though. I know that these two angles are the same. So now I have two pair of congruent angles. These two angles are the same, these two angles are the same, but all four of them are not the same. Let's give them some quick letters here. Probably driving some of you nuts when I skip some letters. Now, if I want to state that these two angles are congruent, again, I'm going to utilize that congruent symbol, but I'm going to name the angle first. So I'm going to say angle ABC is congruent to angle DFE. Now again, very crucial in geometry when you're looking at figures, you never assume anything by their measurements. They have to tell you they're congruent. You can't look at a diagonal and be like, they look the same. Don't assume. Now, they had to tell you they're congruent like this, or just like segments, when we had the tick marks, they can add a little something to the picture here. Right here in the angle, they'll do this. These little arches in here indicate that these two angles are now congruent. If I have multiple angles in the same diagram, they'll do the same thing like they did for the tick marks for the segments. They'll do a double one here. So now that means these two angles are congruent, but yet they're not congruent to these because these ones have two, these ones have one. So that is congruent angles. Now, there are different types of angles. Acute angles. Oh, so pretty. Acute angles measure less than 90 degrees. Less than 90 degrees. They're pretty. They're little. Okay? Right angles. Right angles measure exactly 90 degrees. It's a corner. Now, here's a question for you. Horizontal line, vertical line. Is this a right angle? The correct answer is no. It is not a right angle. You're assuming because of the way it looks. If you have a diagram and they want to show you it's a right angle, they're going to add the little box in the corner. If the little box is in the corner, now it's a right angle. Again, do not assume anything in this class when we're dealing with measurements. Obtuse angle is more than 90 degrees, but less than 180. It does have its breaking point. So it's more than 90, but less than 180. Because once I hit 180, I have now what is a straight angle. If you have a straight angle is formed by opposite rays, so therefore if you have a straight angle, it actually forms another line. Angle bisector. We had segment bisectors, now we have angle bisectors. Does the same thing, but instead of segments, we're talking about angles. The only thing that can technically bisect an angle, though, is another ray. So it's a ray that divides an angle into two congruent angles. Remember, if they're congruent, they have the same measure, the same number of degrees. So, if I have an angle, this is going to be an approximation, folks. If I have this big angle here, and I say that this ray is a bisector of it, again, they're going to have to tell you in the instructions that this is an angle bisector. Don't assume it's one. Be like, oh, it looks like it cuts in half. It either has to say that this is an angle bisector, or on the picture, you will see this. You'll again see those two arcs in there. Now notice these arcs are offset. That's done on purpose. These two angles, this top angle and this bottom angle, are still congruent. They're still the same measurement, but they offset the arcs. There's a reason for this. Sometimes in some of the books and on some of the diagrams, and I don't like that they do this, what they'll do is they'll do an arc like this. If you see one big continuous arc, if it goes all the way through, this one would be referring to this big angle here, the whole thing. I don't like that they use that. Stick to the little ones, don't ever use this, because then people get confused. But the book does this from time to time, so I have to make you aware of it. That is an angle bisector. Okay, now example 1. Now we have to give these rays names. In this diagram, there are in fact 3 angles. There's the angle on the top, the angle on the bottom, and the big angle that is consistent of both of those angles put together. We need to name each of those angles. So, starting with the angle on the top. Its first name is going to be angle ABC. He has another name, angle CBA. That takes care of the angle on the top. The bottom angle, his name is angle CBD. Or he has another angle name of angle DBC. That's the angle on the bottom. If I'm referring to the entire angle, I'm going to call that angle ABD or angle DBA. Now there are 3 different angles, 6 different names. What do you notice that is the same in all 6 of those angles? What is the same in all 6 of these names? Look at this guy right here. Angle B, or the point B, is the middle letter in every single name. Folks, when you name an angle, the vertex is always the middle letter. So this tells you where to start, where's the vertex, and then where are you going. So I went from C to B and then out to A. So the vertex is always the middle letter. Now, sometimes math people get a little more lazy than that. And they're like, 3 letters is too much to write. I don't want to write 3 letters. So if you have a diagram with a couple angles in it, you're going to see this. That does not mean angle of 1 degree and an angle of 2 degrees. This is another way we can name angles. If you see the little numbers shoved down here in the vertex, angle ABC can now be referred to as angle 1. Angle CBD can now be referred to as angle 2. There is no way for me to do a number method though for the big angle ABD. Okay, because I can't put an angle in just that vertex itself. Now there is one other slight way you can name an angle. Just going to do a quick sketch here. QRS. If I have angle QRS, now notice there's only one angle here. Up here I had 3 angles. Here I have 1 angle. If there's only 1 angle, you could name it by just its vertex. So this one I could call angle R, because it's the only one there. Up here I can't say angle B, because I don't know which one you mean, the top one, the bottom one, or the big one. So again, if there's 1 angle, you can use it just the vertex in his name. Next example. Again, reading directions is very key in doing these. In the diagram, ray BD bisects angle ABC. So BD bisects ABC. It cuts it in half. Find the measure of angle ABC. So if BD is a bisector, you can do this now if you want. Add those little arches in there to indicate that those 2 angles are congruent. So since BD is a bisector, this angle is congruent to this angle, which means this measure equals this measure. So 8x minus 16 equals 4x plus 20. Do your algebra. I got x equals 9. Hopefully you got the same. Now, did it ask for x? No, it asked for, see this little m here? There's no m here. This is angle ABC. This means find the measure of angle ABC. We got to find the measure of angle ABC, which means I got to take this 9 and plug it in. I'm going to take that 9 now. ABC, take note, ABC, that's the big angle. So I'm going to take this 9 and I'm going to plug it in here. And I'm going to take this 9 and I'm going to plug it in here. Because I need both of those and put them together. Now, some of you might be thinking, well, why don't you just plug it in this one and then double it because they're the same? I want to check my work. I'm going to plug it in here, plug it in here, make sure they come out the same. So because I want to get that 100%. I want to make sure I get that A on that test. So I'm going to plug that into both of them and make sure I got this answer right. So 8 times 9, minus 16. 8 times 9, 72, minus 16, and you get 56 degrees. Plug it into the second one. 4 times 9 plus 20. 4 times 9 is 36, plus 20, 56 degrees. So I got 56 degrees for both of those angles. So since they came out equal, that means this guy is correct. Still not my final answer though. I have to take these 2 and put them together to get the big angle. So the measure of angle ABC is 56 plus 56, or 112 degrees. There's my actual final answer. I want you to try these 2 questions on your own.